Hi everyone, and back to grade 12 maths. Welcome back. Grade 12 math with Mr. Simons. We'll make maths simple and get you exam ready, right? So again, we're looking at cubic functions, but now we look at November 2012, where drawing and the equation is given to you, right? So let's look at the question. The graph of the function f of x equal minus x cubed minus x squared plus 16s plus 16 is sketched below. You can see the graph goes concave up first to concave down. Calculate the x-coordinate of the turning points of f for 4 marks. So there we have the turning points, we want the x values. Calculate the x-coordinates of the point at which f prime x, so the first derivative, is the maximum. So once I bring in the maximum, you should know we must find the derivative and make it equal to 0. So yeah, technically we're testing, can you find the second derivative? Right, so that is related to that drawing. Then they say consider the graphs of g of x equal minus 2x squared minus 9x plus 5. So they gave us equation of a parabola. Determine the equation of a tangent to graph at x equal minus 1. So that's a very common question that we must know, that will be tested somehow, either this way or the way in reverse, where we work and give you the equation like in the previous slide of the tangent, and you must work back to front. For which values of q will the line y equal minus 5x plus q not intersect the parabola? Right, so there we first need to find where they intersect. So we have to find the point of intersection, so that from there we can work further. Then for the last one, given h of x equal 4x cubed plus 5x, explain if it's possible to draw a tangent to the graph of h that has a negative gradient. Show all calculations for 3 marks. So as I say, and I maintain it, pause here, see what you can answer, make a note of what you don't know. As we work through the corrections, so we work through the corrections. Then look at correcting your mistakes and use a different color pen, and then practice them till you don't make that mistake again. Right, so let's look at the solution for the first question. Right, so calculate the x-coordinate of the turning point of f. So turning point means I have to find first derivative. So fx equal minus x cubed minus x squared plus 16x plus 16. That is my normal equation. Find the first derivative. F prime x, 3 times minus 1 would give me minus 3. 3 minus 1 would give me 2. 2 times minus 1 gives me negative 2. 2 minus 1 would give me 1. 1 times 16 gives me 16. X 1 minus 1 becomes 0. The first derivative, a constant, falls away. We must equate the first derivative to 0. So we give you 1 mark for the first derivative and 1 for equating the first derivative to 0. Then we're required to find the factors. So 3x squared, 3 is a prime number, can only be 3x times x. Factors of 16 I must use in such a way that I get to 2. So positive 8 times negative 2 gives me negative 16. But negative 2 times 3 gives me negative 6. 8 minus 6 would give me positive 2. So x equal minus 8 over 3, or x equal 2. So another mark for factors and 1 mark for the x values. If they asked for the y coordinates as well, these two must go back in the original equation. Right, 9.1.2, calculate the x coordinate of the point at which f prime x is a maximum. Right, so for 3 marks, maximum, so whenever we say maximum or minimum, we want the first derivative equal to 0. So first derivative is what we're using, was minus 3x squared minus 2x plus 16. So we find the derivative of the first derivative, we're technically finding second derivative. So 2 times minus 3 minus 6. 2 minus 1 gives me 1. 1 times negative 2 gives me negative 2. 1 minus 1 gives me 0. So minus 6x minus 2 equals 0. Remember, must equate it equal to 0. If I take 6 over, we have to become positive 6. So I would have negative 2 divided by positive 6, which simplifies to negative 1 over 3. So there is my 3 marks. Right, so that were the questions in relation to the drawing given. Alright, Look at the next set of questions. Right, consider the graphs. Minus 2x squared minus 9x plus 5. So there my highest coefficient is squared, x squared. So I'm dealing with a parabola. Determine equation of the tangent graph of G at x equal minus 1. So they make contact at x equal minus 1. So therefore we want the equation. So there we first need a gradient of the tangent and the point of contact. So first derivative, 2 times minus 2 gives me negative 4. 2 minus 1, x to the power 1. 1 times negative 9 gives me negative 9. And the constant falls away. Substitute x minus 1 in there. So g prime negative 1 equal minus 4 times negative 1 minus 9 gives me negative 5. So my gradient of my tangent would then be negative 5. So for gradient, we find first derivative. We substitute the point in that's given. And the answer we get, that's the gradient of my tangent. For point of contact, meaning where the 2 points or the 2 graphs make contact, we substitute minus 1 into the original equation. So that would give me g minus 1 equal minus 2 times negative 1 squared minus 9 minus 1 plus 5. So 5 plus 9 gives me what? 14. 14 minus 2 would give me 12. So my point of contact, POC used to be a group, Prophets of the City, right? But point of contact minus 1, 12, South African group, y equal mx plus c. So my gradient is negative 5. Now we sub in my point of contact, which is minus 1 and 12. So this state that x is minus 1 while y is 12. Minus 5 times negative 1 would become positive 5. But if I take it over, 12 minus 5 would give me 7. So c equals 7. So my equation, y equal minus 5x plus 7. So 1 mark for the first derivative. 1 mark for finding the tangent, gradient. Then 1 mark for point of contact. And then 1 mark for the equation. So that is how they put that 4 marks together. So 9.2.2, for which values of q will the line y equal minus 5x plus q, so there you see we have the same gradient as the tangent, not intersect the parabola. Right, so minus 5x plus q equal minus 2x squared minus 9x plus 5. At that 2 points they would make contact. No? So if I solve for q, if I bring for negative 5x over, minus 9x plus 5x, become minus 4x plus 5. Right, now I'm going to complete the square. So by completing the square, I first take out negative 2 and I'm left with x squared. Minus 4 divided by negative 2 gives me plus 2. So that gives me plus 2x plus there half of 2 would be 2 divided by 2 squared. Add it and subtract 2 divided by 2 squared. So that becomes 1 squared minus 1 squared. So I'm adding 0. And there 5 divided by negative 2 would give me negative 5 over 2. Right, so 2 over 2 gives me 1 squared, x squared. Square root of x squared, x. Square root of 2 over 2 squared or 1 squared is 1. So that gives me x plus 1 all squared minus 7 over 2. So minus 2 minus 5 would give me minus 7 over 2. Then from there, if I multiply the negative 2 back in, that would give me minus 2. Sorry there, just had a moment thinking there. Minus 2 times the bracket would become minus 2x plus 1 squared, and minus 2 times negative would give me positive, but 2 and 2 would cancel, and I'm left with 7. Therefore, q, which equals 7 at that point, must be greater than 7. Right, so if it's 7 there where they're touching, see there, I can't move the graph by saying less than, because I'm going to bring it into the graph. Right, I want it not to intersect, so I have to move it to the right. Therefore, q must be greater than 7, because the maximum length would be 7. Or point of contact would be at 7. and there correct inequalities. 1 mark for 7, 1 mark for my inequality saying greater than. Alright, let's look at the last problem. So explain, we're given hx equal 4x cubed plus 5x. Explain if it's possible to draw a tangent to the graph of h that has a negative gradient. Show all calculations for 3 marks. So we have h of x, 4x cubed plus 5x. To get the tangent or the gradient of the tangent, right, so we normally find the first derivative. Right, so h prime x equal 12x squared plus 5, 3 times 4 gives me 12, 3 minus 1 gives me 2. 1 times 5 gives me 5, but 1 minus 1, the x falls away. So I have 12x squared plus 5. So we need to understand for all values of x squared, that x squared will always be greater or equal to 0. Right, at the same time, I'm multiplying x squared by a positive. So if x squared is always positive, I multiply it by a positive, then that 12x squared will always be positive. If I take a positive answer and I add a positive to it, it will stay positive. Right? So therefore I can now state that 12x squared plus 5 will always be greater than 0. So my gradient for my tangent there, first derivative, would always be bigger than 0. Therefore all tangents drawn to h will have a positive gradient. It will never be possible to draw a tangent with a negative gradient to the graph of h of x. Right, I hope you enjoyed the lesson. I hope you work peacefully through it and you understand. And if there's anything that's not clear, feel free to comment. Right? All I ask is that you be diligent and resilient in what you do. Continue practicing these exam questions over and over. I'm going to continue uploading as many as I can find and try to put them in order for you so you can continue becoming better and better at what you do. God bless. Bye.